All right, so a cubic equation, first of all, if I give you the rough graphs, so either they are like this, or the graph is going to be like this. Now, if you look at both of these graphs, overall, the gradient is rising from extreme left to the extreme right. This is again rising, although it is falling for this particular part of the graph, but overall, it is rising. Okay, so this is you're going to obtain is the coefficient of x cube is positive if you have a positive a. Okay, and if the same thing, if a is a negative, the coefficient of x cube is negative, then you will have the same situation. In one of the situation, you will have overall falling gradient. The graph will have a negative gradient, or it is going to be like this. Okay.
Yes, sir.
So in this one, there is no turning points in these two situations, and in these two situations, we have two turning points. That totally depends on the components of it. Okay, now I'll be continuing with the how to draw a rough sketch of it. For example, if you're provided with a cubic equation and you have factors as x into x minus 1 to x plus 3. Okay, then exactly same as square like a quadratic one. So this over here, technically for this particular factor, can I rewrite it down as x plus 0, the first factor? This one, can I rewrite it down as x plus 0? So one of them is going to be 0, another root is going to be positive 1, and then it is going to be minus 3. So the graph is going to cut through these 3 points. So one of them is -3, the smallest one, and then it's 0, and then it's +1. So this is how your graph is going to be. So if you draw, and if you look at the graph carefully, it is, if you even if you expand it, you will have a positive coefficient of x cubed. The x here is positive, x here is positive, and x here is positive. So plus times plus times plus is going to be plus. So you have a positive coefficient of x cubed, which is going to give you overall increasing positive gradient. So the graph is going to be either of this nature or this nature. But over here, I can clearly see it is cutting through the x-axis at these 3 points there. I'm going to try drawing the rough graph of it. This is how the graph of this equation is going to be. Okay, got it? Hello?
Yes, sir.
Okay, so these are the roots here. And just in case if you have the equation as, okay, so I'm going to take an example which is written in the book now. In the book, it says y equals x minus 2, and then 1 minus x, and then 1 plus x. Now you can clear, if you want to rearrange them, you can do it for your ease, and that's going to give you, that's x minus 2. If I take the negative sign common from here, that's going to come out over here. The negative sign from here, I brought it over here. And then inside, I'm going to get x minus 1. As I have taken negative as common, this negative x has been changed to positive x, positive 1 to negative 1. And then the last one stays as it is. I've only swapped their places. All right. Now, as you can see, the coefficient of x cubed is negative. Now, the overall graph is, or the overall graph is going to fall. It is going to have a negative gradient. All right. Now, the roots you can clearly see is +2, +1, and then -1. So I'm going to mark these points on the graph. -1, +1, and then +2. So these are the 3 points from where the graph is going to cross the x-axis, and the graph is going to be have a negative gradient overall. So this is how the graph is going to be, like this. Got it?
Yes, sir.
All right, this is about the cubic equation. Okay, now a case of a tangent over here. Now, for example, I have something like this. Let's say we have y equals to x minus 1 whole squared times x plus 1. Now you can see we have a squared thing here, so it is going to be tangent at plus 1, and it is going to cut through the x-axis at minus 1, and the coefficient of x squared, x cubed, is going to be positive. If you look, this is positive, and overall the equation is positive as well. So overall the gradient is going to be positive, from means from left to right it is going to rise. So let's just mark the 2 points, minus 1, plus 1. It is going to be tangent at plus 1. So the graph is going to be tangent here, and then it is going to cut through minus 1. So the graph is rising like this, and it is tangent at this point. This is how it is going to be. Plus 1, minus 1. Got it?
Got it, sir.
All right. And when is the situation of a whole cube? All right. Then basically in your syllabus, then you should know. Okay, let me just write down an example. Let's just say it's y equals to x minus 2 whole cube. Okay, when it's x, then know that it's plus 2 over here. Now this plus 2 is over here. This is how the graph is going to be. That is going to be the point of inflection over here. It is not going to have turning points the way we are having up here. Have two turning points here. All the examples we've done up to now, they have a turning point, but this is not going to have a turning point. It is only going to have a point of inflection where momentarily the gradient gets to 0 and then it starts rising again. Okay?
Yes, sir.
All right. So you can even check all of these the graphing software. So, um, okay, so if I try drawing the graph for this one, which was x minus 2 whole cubed, so x minus 2 and the whole power of 3. All right, can you see the graph? It's just at
Yes,
plus
sir.
2. All right, exactly the same way. Let's just do for this one now. X minus 1 whole squared, x minus 1 whole squared times x plus 1. And that's it. Now you can see it is tangent at plus 1 over here. From here we got plus 1, so it is tangent at plus 1 here. And then it is crossing the x-axis at minus 1 over here. Got it?
Yes, sir.
So this kind of works exactly same as a quadratic. Okay, now after that we have graphs of reciprocals. Okay, now two types of reciprocals in your syllabus. Y equals to a over x, and then y equals to a over x squared. Now both of these are going to give you crescents. Okay,
Yes.
If A is positive, then you're going to have crescents in first quadrant and in third quadrant. And if A is negative, then you're going to have crescents in second quadrant and in fourth quadrant. Okay?
Yes, sir.
Whereas if it's a squared denominator, like squared x is the squared, then again you're going to have crescents, but this time neighboring crescents. So m goes here,
Yes, sir.
and the other one goes in the second quadrant. And that's if A is positive. And if A is negative, then you're going to have neighboring crescents, but this time one in the third one and then in the fourth one. Now there's a thing called asymptote. If I try drawing the graph of this one uh, on a graphing calculator and show you, like for example, let's just say we have 2 over x. If you look at this red line, even if I go to infinity and just pick any random point from there, see how to select a point tool. Point. Let's just say that's a random point here. And then if I go back to here, now you see that this point here is on the x-axis, it's 17,700 and this, but it's still positive, means it's above the x-axis, isn't it? Apparently, the
Yes,
red
sir.
line looks like that it is merged with the x-axis, but if I zoom it in a lot, then you will see a point will come where you will see the red line and the x-axis as two separate lines. Do you see them now?
Yes, sir.
Okay, so apparently it looks like that this red line is approaching the x-axis, but it is never going to reach the x-axis. So that x-axis in this case is called the asymptote. Okay?
Yes,
So
sir.
in all of these cases, the x-axis and the y-axis, both of them, they are asymptotes for these two graphs. Now, just a little bit comparative study of this type of situation. In both of these cases, larger the value of k, larger the value of k, without the sign. You need to look into this concept without the sign. So if k, so let's just say I have two numbers, b and a, without sign, okay? Why without sign? For example, if I have -5 and -3, so technically this is bigger, okay? But if I look without sign, then 5 is going to be bigger. So this thing which I'm going to tell you, you need to look into it without signs. So larger the value of k, okay, now I'm going to draw the graph of both of these. Let's just say I have a over x and then b over x. So b over x, I'm going to do it with the purple line, and a over x, I'm going to do it with the white line. So a in this case, as you can see, I've written down the inequality is a smaller number. So the smaller the number, closer it is going to be to the x-axis and the y-axis. And larger the number, it is going to be away from the x-axis and the y-axis. For b over x, this is the one. And for a over x, this is the one. Okay? Same goes for this particular, for the square thing. Same thing. Now let's just look into the graphical. So I'm going to draw the graph of 2 over x first. Okay, so I'm going to take positive numbers, for example, and then 3 over x. Now 3 over x is the blue line, blue curve, and 2 over x is the orange curve. Now 2 being smaller is closer to the x-axis and the y-axis in both the quadrants, as you can see. Okay,
Yes,
got
sir.
it? Okay, now I'm going to take examples of both negative numbers. So let's just say I'm going to draw the graph minus 2 over x, and that's this grayish graph, and then minus 3 over x. That's the green graph. Now, without signs, if you look, 2 is a smaller number, so the gray curve is closer to the x-axis and the y-axis. Okay, but minus 3 over x, without sign, 3 is a bigger number as compared to 2, so it is a bit farther from x-axis and y-axis as compared to the previous one. Got it? Now I'm going to apply the same concept on the squared graphs now. For example, if I have 2 over x squared, so you see the two crescents, the blue neighboring crescents up there. Now I'm going to draw the graph of 5 over x squared. Now 5 being a larger number, it is a bit farther as compared to the blue curve. Okay?
Yes, sir.
Now I'm going to do the same with the negative signs. So basically signs do not matter except that of their position change in the quadrants. Okay, now I'm going to do the graph of minus 2 over x squared. That's the orange graph. Now I'm going to do minus 5 over x squared. Okay, now, technically, if you look, minus 2 is greater number, but I told you you need to look into it without the signs. Now, without the signs, 2 is a smaller number compared to 5. That is why it is a bit closer to the x-axis and the y-axis as compared to the other graph. Okay, got it?
Yes, sir.
All right, now the next thing is about the solving the equations simultaneously. That gives you the number of solutions. So basically looking, it works exactly the same way. For example, you have a quadratic curve and then you have a linear straight line graph. Then the point of intersection is basically the solution of the two simultaneous equations where one of them is linear and the other one is quadratic. So it's not necessary that it applies on a quadratic and linear. It can be applied on any of the graphs, any different type of curves. Okay, so let's just
Yes,
try
sir.
applying the concept on. All right, let me look for a good question there. Okay, so I have a question here. Y equals. So if you open exercise 4C, that's y equals x squared into 1 minus x. That's question number 1, part D. That's page 65. So y is equal to x squared times 1 minus x. And the other equation is y equals to minus 2 over x. In this question, examiner is asking you to write down a suitable equation which would give the x coordinates of these points. All right, in the first part, it's saying sketch the curves on the same axis. So I need to draw the sketches of each of these on the same grid. All right, now for the first one, if I rearrange this as, if I take the negative sign common from the second factor, then it's going to give me negative x squared times x minus 1. So overall, okay, now if you look at this is a cubic equation and with a negative coefficient of x cubed, so the graph is going to have a negative gradient overall. So it is going to fall from left to right. This is a squared factor. So basically it is, if I rewrite this down as x plus 0 whole squared, so basically it is going to be tangent at x equals 0. And then it is going to cut through the x-axis at positive 1. So this is how the graph is going to be. So it is going to be tangent at x equals 0. And then it is going to cut through the x-axis at 1, like this. Okay?
Yes, sir.
So plus 1 and that's 0. It's tangent over there. All right, so that's basically, if I tag this as f of x, then this is basically f of x, the purple one. All right, now I'm going to do the other one with the green. That's minus 2 over x. So that's reciprocal with a negative a. So it's going to be in the third and the fourth quadrant. Okay? So
Yes.
one of them is going to be in the third quadrant, second quadrant, and then the other one is going to be in the fourth quadrant. So as you can see, both of these graphs, they have two intersection points. So if I solve them both simultaneously, we are going to get two solutions for this one. Now state the number of points of intersection. So there are 2 points of intersection. And it's saying write down a suitable equation which would give the x coordinate of these points. You're not required to solve this. So, okay, now you just need to combine the two equations for x coordinates. It means you need to write the equation in x. So I'm going to compare the two y's here. Y equals to this one and y equals to this one. It means x squared times 1 minus x equals minus 2 over x. Okay? So x squared times 1 minus x equals minus 2 over x. All right, so x squared minus, okay, x squared minus x cubed plus 2 over x equals to 0. Okay, so I brought this over here because I have denominator as a variable. All right, now I'm going to take an LCM here. X is the LCM. So x cubed plus x raised to the power 4 plus 2 equals to 0. And x raised to the power 4 plus x cubed plus 2 equals to 0. That's your final answer. That's the equation which is going to give you the x coordinates. So if I try drawing the graph of just this equation, you see that what do you get? You should get two answers for this one. Means it is going to cut the x-axis at two different points. So x raised to the power 4 plus x raised to the power 3 plus 2. Oh, it's not cutting at all. Can you check the answer for this one, please? Maybe I've made a mistake. Oh, it's a minus sign there. That was minus. So this is going to be minus. So basically, x raised to the power 4 minus x cubed minus 2 equals to 0. That's minus. That's minus. Yeah, it is cutting the x-axis at 2 points. Can you see?
Yes, sir.
All right. All right. Next is it wasn't required to draw the graph of this. I just wanted to show you if you like. Basically, I'm trying to solve them two simultaneously. This is the new equation in x. So if I just plot the graph of this, this is going to should cut the x-axis on 2 points. Means it has two answers, which you can clearly see from the original graph as well. Got it?
Yes,
So this
sir.
is how we solving the simultaneous equations together. All right, now the next and the very important concept is about the transformations of the graph. Okay, now basically there are three different types of transformations. So it will require you to recall the concepts of transformation from your IGCSE. Over here, we will be doing, in your IGCSE, you did the transformation of geometrical shapes. Over here, you will be doing the transformation of um, the curves of the graphs. Okay. Now, there are three different types of transformation when it comes to graphs. One is translation, which is same as, which has exactly same purpose as that of the geometrical shape. The other one is reflection, again the same. And then there is stretch. If you remember, we didn't do stretch because it was removed from the IGCSE syllabus, the stretch of geometrical shapes. But when it comes to the graphs, these are the three only possible transformations. Okay?
Yes, sir.
All right, now before we proceed further, just a quick recap of whatever we have studied up to now so that we can relate it with this topic. Okay, not everything, just a few important things which are going to be useful in order to understand this topic. Uh, if I ask you to draw the curve of x squared, y equals to x squared, how is it going to be? Y equals x squared. Just y equals x squared.
It'll pass through the origin because x will be 0.
Yes, and is it going to be concaved up or concaved down?
Up, concave up.
Nice, because the coefficient of x squared is positive.
Positive.
So this is how it be. Nice. Okay, and if I say I have y minus x squared, then how the graph is going to be?
It'll be the same, but it'll be concave downwards in the lower version of the graph.
Nice. It will be the same, but it will be concave down. Very good. All right, now if I ask you to draw the graph of y equals to x minus 1 whole squared, how would you do that?
It'll basically mean that the graph is gonna pass through x equals to positive 1. So it'll be concaved upwards, but it'll
Is it
pass through.
is it going to be tangent or pass through this?
It'll be no, it'll be a tangent and won't pass through. It'll be concave upwards.
Nice. It'll be like this. Okay.
Yes.
Nice. Okay. If I ask you to draw the graph of y equals to x plus 3 whole square minus 1, what does that mean?
Minus 1 is the y-intercept, and it'll pass
No.
through.
You don't get the y-intercept from this format. You only get the y-intercept from the expanded form. So basically, when you have this completing square format, that's the turning point, isn't it?
Yes.
The same, basically, same concept applies here. 1, 0 is the turning point here. See, 1, 0. Okay.
Yes, sir.
All right. Now in this case, -3 and -1. -3, this one, we change the sign of it, and that's -1. So that's going to be the turning point. So -3 and -1. This is going to be the turning point of the graph, like this. Got it?
Yes, sir.
Okay. So we will be using more or less these type of things in today's lesson. So let's just move on now. All right. Now the first one is translation. We can translate the graph in two different manners. One, definitely vertically, and two, horizontally. Okay, so if I want to do the vertical translation, vertical translation, if you recall from your IGCSE transformation, if I want to translate this triangle vertically, it means I want to move this up. The translation vector would have 0 on the x and any number on the y. By this many steps, the triangle would have gone up or down depending on the sign of the k. Remember?
Yes, sir.
Because this was the x distance and this was the y distance of the translation vector. Got it?
Yes, sir.
So basically, if it's 0 and plus 2, then I'll be moving each point like 0 on the x-axis and then 1, 2 on the y-axis. So if I draw each of these points after the translation, this is how it's going to be. So I have moved this triangle by 2 units up. If it would have been minus 2 instead of here, then I would have taken the same triangle 2 units down. Okay? So that's the vertical movement. So that's vertical movement is known as the vertical translation. But how do we with the graphs here? So first of all, if you want to take the graph, because we're doing the vertical translation, now you have two options. Either you're going to take the graph up or you can take the graph down. If you want to take the graph up, so what is going to happen with the function? Basically, you'll be adding something into it. Let's just take a very constant a. If you want to take the graph down, you'll be doing subtracting something from it. Okay, so let's just take an example here. The graph of x squared had 0 here, so that is why it was passing through 0. If I put x squared plus 1, the same graph would go on up by 1 unit. So let's just do this on a graphing calculator. For example, if you have x squared, that's the graph of x squared, the green curve. If I'm doing x squared and then plus 1, you see the graph is gone up by 1 unit. Got it?
Yes, sir.
All right. So this is how you're doing. So basically, if you want to move the graph vertically in a vertical direction, you're going to add or subtract something into its y, because look at this is the function. I'm adding something into its y, not into its x. Okay, so if you want to
Yes.
look at the same thing in terms of points, for example, if you have a point on the graph, you mark a point anywhere on the curve. If it was xy initially, after the translation, after adding this thing into the graph, which is going to be y plus a, because you're adding something into its y. And same goes for this one, you're subtracting something from its y. Now I'm going to open up the graph again. If you look here, each of these points have gone up on the y-axis by 1 unit. Now let me show you by the, okay, look at this. Now each vertical grid over here is of 1 unit. Now look at this point on the y-axis. On 1, the very same point has gone up by 1 unit, isn't it?
Yes.
And look at this one. This is on 4. This has gone up to 5 because I've added 1 in every value of y of this question. So that is why I'm going to write it down. The entire function plus a. So basically, I'm adding into its y. Okay?
Yes.
And definitely, if you want to do it in the form of a vector, then this is 0 and then a on the x-axis. And then 0, sorry, not x-axis, 0 and then a for the y movement and minus a for the y movement. Got it?
Yes.
चलो, ये हो गया आपके पास vertical translation. Okay, now let's just look into the horizontal translation where you shall be moving a graph in a horizontal direction. The horizontal translation. Okay, in a horizontal translation, what are you going to do? You're going to move the graph as it is, either to the right or to the left. So again, you have two options, either to the right or to the left. Got it? Okay, now what
Yes,
are
sir.
you going to do if you're moving the graph to the right? Okay, I would like you to go back and refer to this one. Okay, now I'm going to draw the original graph here. The purple graph is off. What is the equation for the purple graph? What would be the equation for the purple curve here?
Um, it would be x square,
Yeah,
y
very
equals to
nice.
x
It
square.
will be x squared. That's it. Okay, now if you look at this white graph, it is the same purple graph, but it has been translated to the right by 1 unit. Now, what has happened to its equation? Can you see that?
So which one are you talking about?
Now, this is the graph of y equals to x squared, the purple one, isn't it?
Yes.
Okay, this white curve over here is the same purple curve, but shifted towards right by 1 unit, isn't it?
Yes.
Okay,
Yes.
now what happened to the equation y equals to x squared? Now, what can you compare the equation of this white curve with the purple curve? What was the equation
Uh,
of the?
there's one. It has transformed like one more in the x horizontally.
But what? Look here. It says x
Yes.
minus 1. It has moved to the right, but it's x minus 1, okay? So this is the
Yes.
opposite of what we've been doing up till now. So that's very strange. That is why I wanted you to focus on this one. If you want to move the graph towards the right, okay, earlier I was adding or subtracting in the y. This time I'm going to add or subtract in the x, means in the domain of the function. So y equals to f of x minus a. If I subtract something in x, then the graph is going to move towards right. Okay,
Yes.
you can see this already happening. So let me just do this on the curve as well. Okay, now you have the equation x squared. Okay, that's the red curve. But this time I'm going to do x minus 2 and then the whole square of it. See the orange curve? By subtracting 2 from the x of the equation, the graph is shifted towards the right by 2 units. Can you see the orange
Yes,
curve?
sir.
All right. So in terms of points, now what is actually happening to the points here? If the original points were x, y anywhere on the curve, then now after the translation towards right, there's something being subtracted from the x coordinate of the graph. Okay?
Yes.
No, not the something being subtracted in the equation, which is going to result in which is going to take the x that many steps to the right. Okay, let me explain you from the curve here. For example, this is the curve here, which is passing through the origin. If I do x minus 1, then the same curve would be at plus 1 here, isn't it?
Yes.
X minus 1 whole square. Now, what happens to the x coordinate of this one? Initially, it was 0. Now, it is plus 1. So basically, that many steps which are being subtracted from the x has been added in its x coordinate. Okay?
Yes.
Okay. Sometimes it gets a bit confusing, but all you have to remember is you're moving the graph towards the right. So definitely when the point is going to move on the right if something is being added into the x coordinate of the point. But when you talk about the equation, then you have to subtract that many points from the x of it. Okay, this is very strange. It works in the opposite manner. Okay, now
Yes,
definitely
sir.
the vector of it is going to be a and then 0 on the y because you don't want to move vertically, so that's why it's 0, and a steps on the x-axis. All right, now if you want to move the graph towards the left, then you will be adding that many points into its x. So this way, what will happen if you have the original point as xy, is you're adding the steps into its x, so the graph will be moving towards the left by that many steps. So that is why I'm subtracting in its x coordinate. And the vector is going to be minus a and 0. Let me just show you the graph of it. So for example, if you have x squared, now I want to move the graph towards the left, let's say by 3 units. So what I'm going to do is I'm moving the graph towards the left. So I'll be adding 3 into its x. Okay, so I'll be doing x plus 3 and then the whole square of it. And that you see the gray graph, it has moved towards the left by 3 units. So that is why I written as x plus a. And if you look at the x coordinate of that, initially if it was x, in this case, which I have used as an example, it was 0. Then 0 minus 3, that is why it is at minus 3 now. So that is why x minus a, whatever the current x coordinate is, subtract that many steps from that, and it will be moved towards the left. Got it?
Yes, sir.
So that's the horizontal translation. All right, now just to clarify, what do we actually mean by adding in y and adding in x? Now, y equals to f of x, and y equals to f of x. Okay, and I'm going to take an example for each of them as y equals to x squared and then y equals to x squared. If I'm adding in y, it means I'm adding outside the function, okay? Or maybe even
Yes, sir.
subtracting. But if I'm doing adding or subtracting in the x, means I'm replacing x with that, okay? So it is going to be y equals x plus 3 and then the whole square. So instead of x, this is basically y equals to x squared. Now instead of x, I've written x plus 3. So I've added in its x. Okay?
Yes, sir.
All right. Now I'm going to do the combined translation. That was just horizontal separately and vertical separately. Now, what will happen if you combine them together? All right, now the combined translation, this is how it's going to look like. So y equal combined translation. Combined translation is going to be y equals to f of x plus a and then plus b. You see b is being added in its y and a is being added in its x. Okay?
Yes.
If I want to write down the vector of this one, the vector of this translation is going to be negative a units on the x because I'm adding in its x, so the graph is going to go on the left. So that's why negative a units on its x and then positive b units on its y. Got it?
Yes.
And if I want to explain the same thing as in terms of points, what is going to happen to its each point? So if the original points were x, y, now they are going to be x minus a and then y plus b. Got it? Got it? Is it
Yes, sir.
clear? You can
Yes,
change
sir.
the
It's
sign
clear.
accordingly. If this is minus a, this is going to change to plus, and this is going to change to plus as well. And if this is minus b, then this will be minus, and this will be minus as well. So in short, vertical translation is very pretty straightforward. If you want to go up, you're going to add in the function, and you are going to add in the y-coordinate of the point, and you're going to add in the vector. But if you're doing a horizontal translation, so if you want to go towards the left, then you will be adding in the function, but subtracting in the vector and subtracting in the point. Okay? And if you want to go towards right, then you will be subtracting in the x, adding in the vector, and adding in the point as well. Clear?
Yes, sir.
Great. So let me just put the other way around signs with the purple pen. Actually, I'll use white color instead because I haven't used white in any of these. Minus. Okay, if A is minus, this is going to be plus here. This is going to be plus here. Got it?
Yes.
All right. And if A is, and if B is minus, then this is going to be minus here. It is going to be minus here as well. So you can relate it with the same, with the minus. What happens if the signs are changed? The minus A, over here you're going to have plus A, and over here you're going to have plus A. Okay?
Yes.
All right.
So for what's inside the bracket, the sign is going to change, but for what's outside, the sign is going to remain the same.
Yes. Okay, so now if I ask you to do the x minus 3 whole cubed, means the x cubed graph is going to move towards right by 3 units. Okay?
Yes.
And if I add plus 2 here, so it is going to move towards right by 3 units and towards up by 2 units.
Got it, sir.
Okay? So when you're doing something inside, it works in the opposite manner. And when it's plus 3, it's going to move towards left by that many units. Okay?
Yes.
All right. So this was translation. So tomorrow we have a lesson, inshallah. Tomorrow we'll be looking into reflection and the stretch. Okay?
Okay, sir.
Just a quick question for combined translation. Let me see if you have it in your book.
Okay, sir.
Hmm. I can't find it because the exam questions they have stretch and reflection as well. We haven't done that yet. Oh yeah, I found it. I haven't mentioned page 70. It's question number 2. Question number 2. All right. The part A says sketch the curve of x minus 1 times x plus 2. So that's a quadratic, which is going to cut through positive 1 and negative 2 on the x-axis. So y equals x minus 1 times x plus 2. Examiner wants you to sketch the curve of this one. So x minus 1 times x plus 2. So the roots are going to be plus 1 and minus 2. So on the x-axis, it is going to cut through minus 2 and plus 1 on the other side. Okay. Now the graph of this one is going to be something like this. That's a rough sketch. Okay. Got it? All right. Now,
Yes.
part B, examiner is asking you to, on a separate diagram, sketch the graph of y equals to f of x plus 2. f of x plus 2 means the same graph will be shifted towards left by 2 units. So basically, now the graph is going to be, now this one, 2 units to the left, now the graph is going to cut from here. And for this minus 2, the graph is going to cut through here. Now you will have the same graph as, if I try and make a copy of this one, no, it won't be possible. Say the same graph would be translated towards the left. There's 2 being added in its x. Okay? And part 2 says y equals to f of x plus 2 means the same graph f of x, and then plus 2 is outside the function, means you're adding 2 units in y, so the graph is going to go vertically up. Okay, so the same thing, so every point is going to go 2 units up. So this one would be here, and this one would be here. Okay, so this is how the graph is going to look like. Okay.
Yes, sir.
Get the graph by 2 units up. So we'll work on its accuracy later on, but this is just a rough idea about the translation today, that how you will be actually translating.
Okay, sir.
चल ठीक है जी बच्चे, इंशाल्लाह see you tomorrow.
Okay, sir. Allah Hafiz.
Allah Hafiz.